We continue our work on this vector question. We're going to find Rp now and write it as a column matrix. Alright? Let's just erase some of these things that we have to make space. We have these written over here: 7, 5, 12, 15, 16, 5, 5, 10, 4, negative 10. Good. Can erase them to make space and also to remove some of the crowding. So OR now as a column matrix. Go back to our graph plotter. No, I was looking up here and said OR is RP as a column matrix. That's what I should say. RP. It's RP that we want now. RP. Alright. So let's put in a line from R to P. Good. Let's make some adjustment to our line. Now RP looks like this. So we have PR going straight across like this. So we see what it looks like. Something like this. Oh, let me make it quicker. It looks something like this. And then O is here. And this is what we see. So we see P, R, and O. Now RP would be going this way. Now we cannot make the arrow on the other two sides of the triangle like this, because they will be following, right? They're not supposed to do this. They're not supposed to be following each other around the triangle. When you go from R to P, it's supposed to be opposed by here, and this one is supposed to oppose RP. So we're going to change the arrows on here. So it's supposed to have arrow going from O to P and R to O. So here now, what we see is that RP going this way is equal to RO, following the arrow, is RO plus OP. RO plus OP. Alright? Now RO is the inverse vector of OR. OR was 16, 5, so RO is negative 16, negative 5. So the signs change for inverse vector. Plus OP. OP was what? 7, 5, 7, 5. Now, just before we finish this calculation, let's look again at what we have here in the graph. We see RP. It runs directly over here from above 16 to above 7. 16 minus 7 is what? Is 9. But it doesn't seem to go up or down. So it seems as if we have a change in x from right to left. So we are negative 9, x is negative 9, y is 0. X is negative 9 because it runs from right to left in the negative direction. So it seems as if it's going to be, just from looking at the graph, it seems as if it's going to be negative 9, 0. But anyway, so what happens here? Let's finish the calculation. Negative 16 plus 7 going to be negative 9. Negative 5 plus 5 is 0. Ah, you got it. So it's negative 9, 0. So you see that RP is equal to negative 9, 0. Right, good. Now, of course, you wouldn't take such amount of time, so much time in an exam, right? You want to hurry and finish the question quickly, but you know, that's what I'm doing here is explaining each point in detail, alright? Now, you must calculate PQ, the magnitude of PQ, and hence determine the unit vector, the direction PQ. Alright, let's look back at our graph and see what's going on here. PQ. Okay, this is PQ. Let's try to remember what PQ looks like and just sketch it. We use this already. So the graph says you have PQ going up this way from P to Q. So here we have from P to Q, and O would be somewhere down here. So let's do that. So this is P and this is Q, this is O. Calculate the magnitude of PQ. Okay. Now, looking back, P is above 7 and beside 5. We could see it here. P is above 7 and beside 5. So it's above 7 and beside 5 here. And then Q would be above 12 and beside 15. Alright, so that's what we have there. The magnitude, if we have this as our triangle from 7 to 12, 7, 8, 9, 10, 11, 12, this would be 5 units long. From here to here would be 5 units long, and from here to here would be 5 to 15 is 10. So it's like we have this triangle now. And then this is 5 long, this is 10 long. PQ would be the hypotenuse of that right angle triangle. So the magnitude of PQ would be the length of this side. So PQ squared, using Pythagoras theorem, PQ squared is equal to 5 squared plus 10 squared, which would be 25 plus 100, which would be 125. So PQ would be the square root of 125. What's the square root of 125? Let's get our calculator. The square root of 125 equals 11.18. So PQ will be 11.18 long. So that's 11.18. Alright. Now, that's the magnitude of PQ. One way to write the magnitude of PQ is like this. PQ, that's the modulus of PQ, magnitude of PQ is 11.18. Alright? And they say, hence determine the unit vector in the direction of PQ. Alright. So let's erase to make some space now and deal with this unit vector business. here, PQ, the vector PQ was 5, 10. Luckily I wrote them over here so I can see them. Now, what you have for unit vector is each of these will be divided by the magnitude. Alright? So PQ, a little hat above PQ to mean the unit vector of PQ would be, in this case, and by the way, PQ, you had it originally as here PQ with 510, or you can write it here as 510 like this. So it's a bit neater when you do the calculation. 5 over 11.18 comma 10 over 11.18. So what you have here, 5 divided by 11.18 is what? 5 over that is 0.447. So we have 0.447 comma 10 divided by 11.18. What is that? So let's go back to this and put 10 over it. 10 divided by 11.18. 0.894. 0.894. Alright? Now the unit vector PQ, you can write it here as 0.447, 0.894. Let's write it over here as well. The unit vector PQ is 0.447, 0.894. So that's the unit vector PQ. Alright? Now we can do a little calculation here just to check. If we should find the length of the unit vector PQ, what we would have is that PQ squared equal 0.447 squared plus 0.894 squared. That would be what? 0.447 squared plus 0.894 squared equal that, and then the square root of it. Oh, let's do this part first. So it's 0.999045, 0.999045, and then PQ would be the square root of 0.999045, which is what? Square root of that equals 0.99952, which is just about 1. You can call it 1. Now the thing is, I put the lines up around PQ to represent magnitude. The thing is that the magnitude of the unit vector is 1. So you got this correct. The magnitude of the unit vector here is 1. Alright, using a vector method, determine the position vector of M, the midpoint of the line PQ. Let's do that in a different video. So I will see you then.